everyone, this is Amit Kumar Pandey. We are going to discuss an important topic, FCFS SSTF scheduling algorithm along with scan scheduling algorithm. So let us see what I will say this topic. So first, here are the steps for FCFS scheduling algorithm. The steps are like that: find out the sequence to be serviced. Let us one by one take the tracks in the default order and calculate the absolute distance of the track from the head. Then increment the total seek count with this distance, and currently service track position now becomes the new head position. Repeat all these process until all tracks in request array have not been serviced. Here we take an example for understanding. We have a sequence which we have to service using FCFS scheduling algorithm. The sequence is 176, 79, 34, 60, 92, 11, 41, and 140. And current head position is at 50th number. Now, using FCFS scheduling algorithm, how these requests will be serviced, let us see. Here is a chart which shows you the functioning of FCFS. And current head position is at 50. Then the logic of FCFS is that it service the request in their arrival sequence. So after 50, the head will move toward 176. Then from 176, it will move to 79, then 34, then 60, then 92, then number 11, then 41, and then 114. So in this manner, FCFS scheduling algorithm will service the request. So in numerical, what is the asking? Asking is what is the total seek time? Is how much time you spend to service all these requests. So how to calculate the seek time? The seek count will be the difference from one location to another location. So here we calculate the seek count as 176 minus 50. Then then 176 minus 50. Then we reach 176. So we will add 176 minus 79. Then 79 minus 34. Then 60 minus 34. Then 92 minus 60 plus 92 minus 11 plus 41 minus 11. Then 114 minus 41. The addition of these all will be 510. So seek time for this request using FCFS scheduling algorithm will be 510. This was the FCFS scheduling algorithm. Now we move to next scheduling algorithm known as SSTF. SSTF stands for shortest seek time first. The basic idea of the SSTF is that the tracks which are closer to current disk head position should be serviced first in order to minimize the seek operations. Take the sequence of tracks that have been requested. Head is the current position of the disk head. Okay. Find the positive distance of all tracks in the request array from head, and find a track from requested array which has not been accessed or serviced till now, and has the minimum distance from head. Increment the total seek count with this distance. Currently service track position now becomes the new head position. Repeat all the process until all tracks or all services in request array have not been serviced. To understand better how the SSTF scheduling algorithm works, we take a sequence is like 176, 79, 34, 60, 92, 11, 41, and 114. Current head position is at 50th number. Now see how the SSTF will function. So from current head position 50, it will move to 41 because 41 is the nearest request from the location on which the head is resides currently. So it will move 50 to 41. Then 34 is much closer than 41 or nearest to 41. Then it will move to 34. Then to 11. Then to 60. Then 79. Then 92. Then 114. Then in the last 176. So in the last, we calculate the seek count for this request using SSTF rescheduling algorithm. Seek time will be like 50 minus 41 plus 41 minus 34 plus 34 minus 11 plus 60 minus 11, then 79 minus 60, 92 minus 79, then 114 minus 92 plus 176 minus 114. This difference for the displacement from the current position to the next position and addition of all the displacement. So the total seek count will be 204 for SSTF scheduling algorithm for this request. Now, next scheduling algorithm is scan. So what are the basics of a scan scheduling algorithm? In a scan scheduling algorithm, head starts from one end of the disk and moves toward the other end. Servicing requests in between one by one and reach the other end. Then the direction of the head is reversed and the process continues as head continuously scan back and forth to access the disk. So this algorithm works as an elevator and also known as like elevator algorithm. As a result, the requests at the mid-range are serviced more and those arriving behind the disk arm will have to wait. I take the sequence that have been requested in the ascending order of their time of arrival. Head is the position of the disk head. Let a direction represent whether the head is moving toward left or right. You can choose one of them. You can move the head into the left direction, or if you want, then you can move the head into the right direction. In the direction in which head is moving, service all tracks one by one. Then calculate the absolute distance of track from the head. Increment the total seek count with this distance. Currently, service track position now becomes the new head position, continuing the servicing until we reach at one of the end of the disk. If we reach at the end of the disk, reverse the direction and repeat this process until all tracks are serviced. So for example, better understanding, we take a sequence is like 176, 79, 34, 60, 92, 11, 41, and 114. Current head position is at 50, and direction we choose for moving the head is left. So this is the functioning of scan disk scheduling algorithm. Current head position is on 50. Then we move toward the left. So all the requests which come in between in the path we suggest. Then when we reach at the one end, means on 0, then we reverse the direction of the head and process all the requests coming in the path. Okay. So in the last, we have to calculate seek count for this process. So seek count will be 50 minus 41 plus 41 minus 34 plus 34 minus 11 plus 11 minus 0 plus 60 minus 0, then 79 minus 60, and 92 minus 79, 114 minus 92, 176 minus 114. The addition of all these will be 226. So this is the seek count for this scheduling algorithm for a particular sequence which we have taken. These are the references which I have used in my PPT. Thank you all. Thank you so much.